Okay, let's talk about points, lines, and planes. And let's just start defining these things. So a point literally is just a dot. Usually we use a capital letter. So this would be like point A. And it really just is a location in space. It's a location. Some might even call it a coordinate, right? And to be a coordinate, you kind of have to define some axis. Lots of times in maybe Algebra 1, you would call a coordinate, you'd use parentheses like 2 comma 5. Right? That's a point in space that's 2 over and 5 up. It'd be something like that. A point doesn't have any dimensions. A dimension is typically like a length and a width, a height. It is just infinitely small spot that just references a particular location, typically on some sort of coordinate system that we've chosen. Right? In this case, this is our typical coordinate axis. Y versus x. X representing some horizontal distance, and y representing the vertical distance from 0, 0, which we've called the origin. Again, kind of review of plotting points from algebra. So we have points, and then we have lines. And with lines, we have to be really careful. So a line, we give it a dimension. And a line is going to go infinitely far this way and infinitely far that way, and include actually an infinite number of points. Let's talk about the fact, though, that a line is typically going to be labeled with 2 points. Okay, this is the line AB. And with a line on it, we just put a little, literally just a line on top of it. That's line AB. Okay, line. And then with a line, so it's going infinitely far to the left and infinitely far to the right, but it's not coming out of the page, and it's not going up or down. It's only in one dimension. 0 dimension, 1 dimension. And then let's stay in 1 dimension and think about other things. What if I started at A, again, and now I went that way through point B, but I only went to the right? Well, now we have this thing called a ray, and this would be ray AB. So it's labeling a little bit different. It's a one-dimensional thing, but it only goes infinitely far in one direction. Ray AB starts at A and goes through B. If we wanted ray BA, well, it'd go this direction. Okay? We could have, let's say, another point C over here. And what if we wanted this ray, okay? And we would have ray AC, and then we actually would call those opposite rays. They both start at A, one goes to the right, and one goes to the left. So we call those opposite rays, and again, that's another term we need to know. Okay, and then we can have line segment. What if I was just talking about the space, one-dimensional space, only the line that's actually between A and B, then I'm talking about line segment. And so when you use the word line, you have to be particular about whether it's a line, infinitely long, left and right, a ray, initial point going through B, or a line segment. See the little notation differences? Okay, we got those. Or we can just, sometimes people just call this, line L. And just label it with like a lowercase thing, and then that is line L. Okay, 0 dimensions, 1 dimensions, and then we can have a plane. Planes are a little more difficult to draw, but typically we draw a parallelogram. And the hard part is you have to imagine that this extends all the way that way, and all the way that way, and all the way this way, and all the way that way forever, right? A horizontal plane is everything, literally everything that's flat. So we could talk about pretending the floor extended infinitely far to the right, to the left, forward, and backwards. Now it's still flat, right? You're walking on the carpet and pretend that the entire carpet of Bradley is one plane. The entire ceiling is another plane. You can think of a wall being a vertical plane. Okay, it's a 2-dimensional thing. Points lie on that plane. It's going to turn out that we can talk about 3 points determine a plane, where 2 points determine a line, and we'll get into more of those things in a little bit. All right, let's connect these two and add a couple vocab words. One of these things we're going to call is collinear and coplanar. Collinear. And then over here we can talk about things being coplanar. Okay? Coplanar is points that are on the same plane. Collinear are points that are on the same line. So in this particular line, C, A, and B, assuming that it was supposed to be one continuous line here, A, B, and C are collinear, where I could draw points on the plane. Those would be coplanar. Again, all these kind of definitions that we have to look at. So points, 0 dimensions, line, 1 dimensions, lines, line segments, rays, and then planes having 2 dimensions. Now what has 3 dimensions? Well, lots of things are in 3 dimensions. 3 dimensions, the world we live in, right? 3 dimensions, 3D things, are like prisms, right? That's my attempt at a prism, right? That's got length and width, or length, width, and then some depth, right? In and out of the page. Spheres, right? That's your sphere. It lives in 3 dimensions. Got up, down, left, right, and forward and backwards. A cone, a pyramid, all these things that you know and love are in 3 dimensions. Okay? Most of this unit, we're really just talking about a 2-dimensional things that could live in this paper. Okay? Let's throw out the fact that a coordinate could actually be, think of our coordinate system, our point, could actually be in 3 dimensions. Okay, and we'll reference this more later, but this is a 3-dimensional coordinate grid that has, right, left and right. It's got up and down, and then it's got the dimension that comes in and out of the page. This arrow goes into the page or into this table, and the z-axis comes out of the page, right? You can look at the x-y plane, you can look at the z-y plane, and you can look at the z-x plane. Okay, the z-x plane would be here in red. Hopefully you can see that the z-axis and the x-axis lie in that plane. Okay, the y and x-axis is the blue here. It kind of is the plane that probably appears the most flat with the table. And then the zy plane is this green that the plane looks like it's going into the page and then kind of out at you. And again, it's difficult to draw those planes. But again, that's actually the intersection of planes. So let's talk about that, the intersection of things. I'm going to take this away for a second. So what do you think the intersection of 2 lines are? Well, take 2 lines and draw them. How are they going to hit? Well, they actually intersect at a point. Well, what about 2 planes? Well, take a plane. I can't really draw this one at all, but I can throw this up here again and look at the intersection of the blue plane and the red plane. Do you see that that intersection is actually this line right here? That line right there. What about the intersection of the green plane and the blue plane? Do you see how it's this y-axis right there? Okay. And then if you look at the intersection, again, this one's probably the harder one. The intersection of the green plane and the red plane is this z-axis. So the intersection of 2 planes is actually a line, where the intersection of 2 lines is a point. Okay, so we will be talking about intersections and how that all works. Okay, when we start talking about intersections, another thing we might talk about are the idea of being parallel. Right, we'll use these words. So let's say these are parallel lines. Parallel lines have the same slope and they never intersect. Where perpendicular lines intersect at right angles. And we'll talk about that. If that's a right angle, well then all these bad boys are indeed right angles. They don't have to be straight up and down, right? Right, we'll call those to be perpendicular lines. So we can have perpendicular, we can have parallel, right? These would be parallel. These would be perpendicular. There's actually lots of words for perpendicular in math. Perpendicular, normal, orthogonal, all these words will eventually be used. But this kind of forms the backbone of what we really are going to try to, talk about in this first unit. The next video will kind of go through the major postulates, but this hopefully gets you kind of started, right? Points, lines, and planes. A point is a location in space, and again, it can be a three-dimensional thing, right? We can talk about where it's located, left and right, up and down, and then whether it's out of the page or into the page, right? It's a location space having no dimension. Then we can have a line, a ray, a line segment. We can talk about opposite rays if we really wanted to. We did discuss that the ray AB is not the same thing as the ray BA, because BA would start at B and go to AB, this ray. They're not the same. Collinear just means all three of those points form a line or lie on the same line. Coplanar, points all on the same plane. And then we talked about the intersection, and then we threw out some three-dimensional shapes that we'll get to later on in geometry. We'll analyze prisms and pyramids and spheres, but they all have length, width, and height. Okay, hopefully this gets you a good start. I am going to put these up there, and again, these are going to be on the Canvas page. I think this is a good note. I didn't make these, but these are solid. Kind of reviewed of everything we just did. Points, segments, rays, lines, planes, some definitions and some notations. Collinear, coplanar, and then it gives you some figures over here, and you can practice. Again, this is showing two intersections of planes. You can see the line AB is the intersection of this plane and that plane. You can talk about a line intersecting a plane, intersects the vertical plane at D, the horizontal plane at E. You can talk about C, D, E, and F being collinear. You can talk about E, B, and A being coplanar. They're all on that plane M. You can talk about line L. This is plane N. And you can kind of go through all these directions. You have a ray EF. So ray EF would start here and only go that way. Ray EEC would go the opposite direction. They'd be the same. You can start to ask questions about, is ray AD and ray AC the same? Well, yes, they both start at E and they both go in that exact same direction. So this is a pretty good sheet. You can review this. You can see this on Canvas. That's not a bad idea. And then you can also take a snapshot of this if you want some other thoughts about segments. Again, how they're named, how they're written. Segment AB and segment BA, well, those are the same thing. You're talking about this line segment. It does have a particular length. And again, it kind of goes through what an opposite ray is and the fact that ray AB is not the same thing as ray BA. And down here, they also talk about things. And the other thing I guess they did, lines are skew. And that's not really something we've talked about a lot. But skew lines aren't even in the same plane and don't intersect. So they'd be like, right, let's pretend these two lines are in the same plane, but what if I did this? Nope. They're still never going to intersect, right? They're still parallel, but I can even do this. These lines will still never intersect. This one's going to go up forever that way. This is going to go down forever, and this is just going to go horizontal. So there are skew lines. Again, if they're not in the same plane and they don't intersect, they don't actually have to be parallel. Just because they don't intersect in 3 dimensions, they can just be skewed. Okay, hopefully this helps out and you're on your way to being successful in geometry.